I'm representing our leading strand in a very simplified form because I'm not too worried about this for now. We already sketched that out. These next couple of sketches will be focused on the lagging strand. So here's my DNA helicase, and it's unzipped a few bases. Ta-ta! The furthest towards the 3' end that this DNA polymerase can go is right here on the adenine. So it's going to clip in here and then move from 3' to 5', adding complementary bases. My DNA polymerase started here before moving from 3' to 5', added complementary bases, and facilitated the creation of hydrogen bonds. So now we're going to fast forward this sketch a little bit further. So if we fast forward this a little bit and give helicase more time to move down the DNA strand, what we will get is more DNA that's been unzipped. Drew in my helicase. This time, instead of having a bunch of base pairs that have not been unzipped, helicase has moved farther down, so there's only going to be a few. I'm also going to make note of my ends again to keep track of them. So 3', 5', 5', 3'. And again, that's because here the 5' carbon is going to be exposed on the sugar, and here the 3' carbon is going to be exposed. So when you're comparing my two sketches here, the way I set them up, you can see that this is like part A, where helicase only unzipped a little bit, and this is after some time where helicase has moved maybe from about there when these two were together, and it's unzipped them to this point. Just like we had in the other sketch, we're not going to worry about our leading strand. We're just going to put in here that it is still moving from the 3' to 5' direction. And as it has moved, it has matched all the bases with their complementary pairs and facilitated hydrogen bonds. Again, that's our leading strand, which we're less concerned about here. We've already talked about how that is happening. But now we want to tell the story of how DNA polymerase finishes this piece here, detaches, and moves farther up the DNA strand. We're going to start by giving ourselves a DNA polymerase here. So originally, this helicase had only unzipped to this point, and the DNA polymerase moved from here to here. As it moved down, we know that it added complementary bases, that T, A, T, A. But now, it's come to about the end here, and there's so much more space over here for it to even move in its desired direction, which is the 3' to 5' direction. So this DNA polymerase is going to detach and move closer to that helicase and reattach so that it can move once more in the 3' to 5' direction. So the way I'm going to write this out is that it detached from here and moved closer to the DNA helicase. So I'm going to draw another sketch to show you what this is going to kind of look like as our result, where again we have just a little tiny short piece where the helicase has not yet unzipped, putting in a very rough sketch of our leading strand, You can see it's getting more and more simplified as we continue. Put in our helicase. Here for the lagging strand, I'm also going to add the base pairs that have already been made by the DNA polymerase before it detached. So my DNA polymerase finished up over here, detached, moved down the replication fork closer to helicase, and so it is ready to continue from the 3' to the 5' direction, adding complementary bases. I'm going to leave DNA polymerase about here in the middle, so we're kind of drawing in action. If these bases were C, G, C, G, and I guess we could continue it and say CG over here, the DNA polymerase, as it has moved this way, has added a G, a C, a G, and a C. After it detached from this end, the DNA polymerase moved closer to the helicase, where it started moving again from the 3' to 5' direction, adding complementary bases. So it's going to keep moving from this point until it reaches the place that it has already been. So DNA polymerase will move from the 3' to the 5' direction until it reaches a DNA section that has already been replicated. So the DNA polymerase will move down, get to about here, and it will say, oh, I've been here before. Then it detaches and moves farther up again.